So this report prepared by Dominic and Enrique. So they did a great job. So this is related to the previous lab 4. So as you can see here, these students take it question by question. They take picture very nicely from their handwritten things. So they just insert it in here. They do some highlight. They basically draw the register. They map the value into the register. They said that which one is zero flag, which one is a set flag. And they also show their calculation, how this happened. They justify their answer, right? So they said that, okay, the result is 0, therefore the zero flag is 1. They did a very nice job. You guys can take a, picture from your handwritten, document and include it, or you can use like Word itself and start writing into the Word document and explain it under this question. So it's not necessary to take image, but this is one of the nicest report that I have in here. So as you can see, they spend a good deal of time to prepare this, and I really like the way that they did this report. So I have some question in the discussion board just to give you some idea. So this is the way to go. I'm sure if like they in the future, if they go for any job, if their manager sees the documentation like this, they're gonna love these guys. They're gonna love these guys. The way that they present their work is kind of excellent. I was in industry for many years, and documentation is something of high value where all these managers are looking for. They have presentation, so they want documentation from employee to discuss those in their higher level or management level presentation. So when they see someone doing such a nice job like this, if something happened to the economy, recession comes, the layoff comes, these people are gonna be the last that are going to be impacted. So remember this is of high value to your employer if it shows something like this. You said that they get a screenshot of their program. They show like 2 cases, and then 1 cases with overflow, 1 case with not overflow. And they did a very good job doing this lab. Okay, this is the way to do it. And previous semester, I have like a student that they do not know how to insert an image. So to insert an image, you come in here, right, in the insert mode. I don't know whether you can see my screen or not. And you can click on the picture and then browse to your image and include it. I've seen students that they take like 6 screenshots of their program, and when they download their assignment, they download all those screenshots individually. If you take a screenshot, it should be documented. It should be included in your lab report or your assignment. Some students, they upload their cover page separately. Basically, the meaning of cover page is that you have a document like this, big document or a small document. Then this document has a cover page. Cover page is the first page of that document, and it should be attached to the document. So do not send it separately, please. So the other things, what are the questions that you guys have? Okay, this is the case for your assignment and for your lab. For your assignment, when it is like a quiz type of assignment and multiple choice, you don't need to do cover page, because basically you are not delivering some sort of say kind of things or programming kind of things, right? But when this is programming questions in your assignment or some sort of say question in your assignment, you are required to include the cover page for your assignment. You have a different cover page for our assignment. So right now it says here lab report. For our assignment, it says that assignment, and then assignment number and the contributor to those assignments. The assignment cover page also is available in the course canvas page. Okay, one of the reasons why I'm doing this, that's a good place to start this discussion. Basically, right now we are in the process of ABET accreditation. So what is ABET accreditation? ABET is an organization that come and evaluate a given program in a given university and check the standard of that education system in a given institution. If the standard education is meeting their criteria, then they give you the stamp of ABET accredited. So what is that for? So is it important to have ABET accreditation or not? The answer is yes, it is very important. Some institutions, especially governmental institutions, when they hire, they want to see that the institution is ABET. So they're asking, is your institution ABET? And if your institution passed that level of assessment, we say yes, and they include you in the evaluation process in the next step. If I want to give you another example of this, how this is working, you know that in medical field, we have like FDA approval products and we have non-FDA approval products. People, when they see that something is not FDA approvable, they tend not to use it. So in industry is the same, especially industry that's related to the states and to the federal government. They are kind of, most of them are looking for like students that comes from institution with ABET accreditation. This is what we plan to do here for computer science, IT, and mechatronics. For mechatronics, we haven't still started the process, but for IT and computer science, we start the process. I'm part of this committee to make this happen. We always collect data from different courses and create assessment of those and include in our archive so that when ABET comes into your 3 years, they could look at those data and see that we are following some standard procedure in our teaching. We are, having very good level of high quality education institution, and they're gonna hopefully give us a stamp of ABET after 2 or 3 years. So we are collecting this document. So that's the point. So when we are collecting this document, there are such multiple criteria for each course that need to be evaluated. So when we evaluate those things, then we have to provide evidence. So what are the evidence in teaching? Your lab report, your assignment, your exams, midterm exam or final exam, all these teaching material. So when we are evaluating a specific criteria for ABET, we need to include those documents in ABET archive and say, okay, this is what we saw in the student, and unfortunately, some of the students didn't satisfy that criteria, and this is the way that we are going to improve it. So far, for example, we haven't taught like COMP-162 in last 5 years. In Linux, it was kind of in Windows. So this is not very industry-oriented course in that way. So now we change to Linux-based system programming so that student can use this one for writing device driver, they're writing a small operating system for embedded systems that you are going to see everywhere in your fridge, your toaster, your printer, everywhere. So they are having operating system, and all these operating systems are Linux. So therefore, we are moving to this direction. Yes, this is difficult for a student at the beginning. Well, now we are changing the curriculum of the university. We are trying to include like C at the beginning. We are trying to talk to those maths, teacher at the university, telling them the importance of student knowing to do binary arithmetic operation easy. So when they come to these programming courses, they are ready. So we are actually on the route of becoming a better institution. So we talk to ABET guys when they come to our university. We explain ourselves and we explain the education quality that we are following. And if they are happy with the documentation and our justification, they're going to give us this ABET accreditation. This is basically a certificate certifying your degree, that this degree is of high quality. And we needed that. You needed that in the future for your employer. How do we do it? We, as an instructor, responsible to make sure that we can get that for you. I'm working with other instructors in the department in collecting those reports, and fortunately in 2 or 3 years we are going to be ABET accredited. Okay, so So because I explained this because you might be surprised saying that, oh, okay, this instructor is harsh. He's asking us to do cover page. Who does the cover page? Why the cover page is important? So why is asking us to do a lot of different things? This is the reason. All right. So much off tangent topic today. Okay, let me go back to the lab and start the technical part of this session. Hopefully you guys got some useful information and understanding how things work, how things improve, how things are certified, and how your work is related to those certification and also your future. Okay. I probably need a break. I'm really freezing right now. I don't know what I'm gonna do at next step. Okay, next step, what I wanna do, your assignment, your lab basically has two activities. And one of the activities is commenting, provide comments for the given file that provided to you. So basically go to the file and explain each line. So what is happening in this line? What is happening in this line? And you're gonna be answering those questions. And the other one is programming question about how you basically do the multiplication operation for two integers number getting from input, how you do that without using the multiplication operator mul, because you haven't still teach mul. What you want to know, is there any way that we can do multiplication without using the mul operator? So this is the activity 5.2 that we're going to go through it. I want to go through this and tell you the algorithm, explaining step by step how this can be done, and probably show you a bit of code to give you some idea from where to start, how to do the things, and how to finish it up. Okay, before getting to this activity 5.2, I guess I haven't been sharing this. Let me quickly share this one. Okay, so this is the lab that I was talking about. So this is activity number 2 that we are required to write a code to multiply two integer numbers coming from the input without using the mul operator. So this is that. And then this is the first activity regarding the file lab file1.asm. Basically, you're gonna go through that file and then add necessary file to, okay, first thing you need to do this, to do this activity is to run it. Now for this assignment, I only provided you with the file. I didn't provide you with the auxiliary file. Okay, what are the files that are required to run this program? So you need to put all those files in the same directory and then run it. How do you run it? Because it involves those macro, you run it with the .run sh command. First thing is to run it. If you successfully get 10 points, easy. No problem for this because you have been practicing this for your assignment and for your previous labs. Second thing, provide comments in front of each line of the code explaining what each line does. And then add a snippet to the file to print out the outputs of the add operation. So let me go through that. Finish activity 1 together, and then give you some times, like for about 5 to 10 minutes, go through that file, try to run it. And then I come back for activity 5.2 to provide you some explanation, give you some background, telling you where to find the documentation and an explanation in the video lecture and lecture slide. So I'm gonna coming back to this after the break. But now at this point, I would like to share my program with you, providing you a bit more detailed information. Okay. So let's do that. Ah, this is a Friday, huh? Friday is supposed to be a fun day. It is a fun day. I know you guys love this course. So, okay, this is lab 4. So you guys can see my screen?
Yes, sir.
Good,
Yeah.
good, good.
Yep.
Perfect. Okay, I'm gonna copy my lab file. This is my COMP-162 lab. Give me option lab file. So I want to copy that in my current directory. My current directory is dot. So I want to copy a directory. So I put -R option because that is for copying a directory in Linux. Then hit enter. So what do I have now in my current directory? I see that lab file is copied in here. Now I'm gonna go inside of that using what? Using cd command. So we go there, take ls. Now I see two things. I see lab 5 solution that I'm gonna show it to you. And now we have module 5 lab document. Okay, I go to the cd using cd command to lab solution. I take that listing to see what I'm having in here. So one of the first question was, I want to run this file basically. So what are the files that are required to include in my current directory to be able to run it? Okay, what are the files that are needed to basically to run this command? You see that ASM shouldn't be there. Therefore, we just run this. It says, okay, there's a way to run it. You enter one number, you enter second number. And it says that, okay, and from 1 to 5, how do you rate your learning process in COMP-162? I literally learned a lot, so I give 5. And it's going to print out something, right? Basically, this sum file is not included in the file that you have. In the file that you have, when you run your function, it's going to tell you into the first number, into the second number. Your rating is always 5. And then it says that the program is successfully executed, but you don't have this sum addition. This is one of the tasks in activity 1, activity 5.1 to add a print command to your code to print this out. So let's take a look at the code. Let's take a look at that. So this is a file that you have been provided with. Lab 5 file, was it 1? Yeah, this is 1, I guess. So we're gonna see the content of, okay, before we see the content of this file, right? So there was a student asking me, okay, I'm getting permission error when I run this command. So I guess now all of you know what the issue is. Then basically you don't have a proper execution permission, then you cannot run the shell script for this given file. For example, when that happens, you can basically check it using this command, ls-la. It gives you all the files in the current directory and the level of permission that you have for each file. This was included in your tutorial in your first lab. It tells you what these things mean. So first is read privilege, the second is write privilege, then the execution privilege, and then this one, the rent. So if you take a look at the run SH, right now you see that as a user, I have the execution privilege. And it means that I can run it. So when you don't have the execution privilege, how you can give execution privilege to your run or the shell script? It is easy. You can give it all the permission a file required, 777, to make your job easy. Just give it that. Or if you don't want to do that, going to be very specific for it, you can say just +X. +X add the execution permission to your file. So if you don't have that permission, then it gives you that permission. So always as a programmer, when you're working with Linux, listen to the command and error messages that Linux is providing to you. They're very useful. So one of the things that I was telling my student at the first semester coming here, I said that communicate with your computer. The computer talks to you. So you talk to it, you listen to your computer. When there is some error message coming out in Linux environment, you listen to it, you read it, and then you take the next step. Okay, so what we were talking about so was like file I guess I'm typing it right, lab5 all1.asm. So this is a file that's provided to you. So we use Vim editor to do that. So we go to lab5 activity. As you can see here, I wanted to introduce to you a new segment in your assembly code. If you remember, we talked about the segmenting of assembly code in the first, second lecture. We said that how the command column is, what is the arguments column in a given assembly program, and how many section or segment it has. You see that this segmentation, this kind of segmenting a code or sectioning the code or framing the code in assembly, you so far had two segments. You had segment.data before when you introduce your data. You remember that for your Hello World program, you put the Hello World message in the segment.data. Basically, .data in your memory map is going to be part of your memory. And also segment.bss is another segment in your assembly code that's going to be another part in your memory map. So they're going to be having different section in your memory. All these segments are going to be there. So previously you had segment.data and segment.text where your code goes, right? And today we learn about another segment called segment.bss. So what is this BSS? What is this abbreviation? I don't know, but the only thing that I know is that in this segment, we include whatever uninitialized variable or data that I want. So why uninitialized? Because I define some container in my code, right? At the time of writing, I don't know what the content is going to be because I, for example, introduce an intermediate counter for my program. And this intermediate counter could have any values during the execution of the program. It's not only one value, but the only thing that I care when I define this uninitialized data is the size of it. For now, let's just tell you 4 different sizes that you can use, but in the coming lectures, you're gonna be having more detailed information about this keyword. But for now, listen to this. So reserve D means reserve double word. Each word in 32-bit hardware architecture is 16 bits. Double word is 32 bits. So when you say reserve double word 1, basically an input 1, so it creates one kind of like a label at your memory map, call it input 1. And then it needs to designate or to allocate part of that memory to this input 1. So how do we do it? Using this keyword. How many bits do you want to allocate? Using this one. So this keyword tells you the reservation is double word, means that 2 words means that 32 bits. Therefore, when the software is running, it tells the operating system, okay, I need 1 word of 32-bit length and the name of the label for that memory location, I need it to be input 1. You know that in C, you define your variable using saying that, okay, integer A or some other name, unsigned integer, for example, B, right? and you don't care about the bit length, the integer. When you say integer, then the system automatically, depending on a compiler, it's gonna give you 4 bytes because that's something happened underneath. But there are some guidelines for your C program that says that when you say integer, it means that it's going to reserve a memory location of 4 bytes for you. Here also is the same, different kind of commands and syntaxing. So it said reserve double word, means that reserve 2 word, means like 2 word each 16-bit, 32-bit, and how many of them? One of them. So you create 32-bit space in your memory, and we call it input 1. And then you have input 2. It's going to be your second variable. In C or high-level languages, we call it variable. Now we call it label, memory label. We don't call it variable. So it's going to be second memory label, and also you give it a space in the memory as much as 32 bits or 4 bytes. How many of them you can define? For this program, we only need 1. So can you define hundreds of them? Yes, you can define basically a label that contains like hundreds of double words in the memory. Now, for us, because we want to read 2 numbers, we just need two variables. That maximum length of this variable are going to be 32 bits. So these are going to act as uninitialized data for us. So when we read something, then we're going to put that number into that space in the memory. So we use this. Previously, we have segment.data. Your program also can have segment.data. Now we can see segment.exe here, segment.text. So this is where our code goes, right? You remember that this is the SQL file. We said that your code goes in here. Right now, you don't worry about these 2 commands. This is going to be taught to you later in this course. So you're going to put your code in here, and then you put in code in here. One thing else that I want to show it to you using this program is that you see that now I brought down the segment.data at the end of this file. So why is that? Why I didn't bring that up at the beginning of the file, right? Why didn't bring it over here? Can it be here? Yes, it can be before segment.ps after this include command. But why I brought it at the end of my file? You know, first intention was to tell you that, guys, it is possible for this segment to be moved around in your file when you're writing the code. This is possible. So you can have the segment.data at the end. You can even have segment.pss at the end. Why? Because assume that you have a complex program. You're writing a device server, and this is so long, and you have so much data to present in the segment.data, right? You have so much data, or for example, in segment.pss, and it gets too big and too large. So when somebody is going to open your file, he has to go through all these data definition first, and then get to your program later. So some people, it's a matter of styling. So some people prefer to have those segment.data at the end of their code, and because there are going to be so much of them, so that when somebody look at their code, they could right away go to the segment.text and see what is happening in the code. If they don't want to spend time on knowing like those data, they want to see the code right away. Therefore, some people prefer to include those like 5 or 6 pages of the data definition at the end of the file. So this is the way. This is a matter of style. You want to bring it up? Yes, you can bring it up. This is a matter of style. You prefer to bring it up, bring it up, and there is no penalty for it. Just the philosophy behind that. Okay, so what do we know now? So one of the So I've been reading one of the comments in the discussion board. There was a student saying that, okay, we are doing this assignment. It was like an early discussion board that we have. So we haven't been provided any instruction, or what was the other word that she has used? What's another word? I don't know. So we haven't provided any instruction in for the coding. So the time, so to answer that question, I don't know what the command really means, like any instruction provided by me. So, but at the time when I explained the Hello World program, I went through all these steps. And now hopefully the student can see what these what this means, but I asked her to have a meeting with her to clarify for me what exactly means not to provide an instruction. And I want you guys to be to read your comment before posting it into the discussion board. If you are meaning something like, okay, that in the previously, like my previous courses, I haven't been taught this one and I don't know, so maybe that's acceptable. But when you say, if you come to the discussion board and saying that no instruction has been provided, considering that for each module we include like 20 different files of videos, a slide, and lecture note, that is kind of not a fair assessment of what I'm doing in here. So just it comes to my mind, okay, so why they're saying this one? So what does this mean? Especially in a discussion board, that's act as a negativity, and the other student gonna looking at that. Oh yeah, no instruction is provided for this. So why no instruction is provided this? Why you are doing this? So be careful about the comments that you are making in the discussion board. Make always, okay, you have some criticism, so you can document it. Okay, this is the part of the code. I understand line 1 and 2, but I don't understand line 3. Don't be kind of come into the discussion board, say, oh, this is so complex. I don't know what to do. I stuck in here. I stuck over there. Just explain what you are looking for so that your instructor and your classmate can provide you answer. Don't come and say, okay, I'm stuck. It is too difficult. So that's not going to help you. And nobody can help you because basically no one understands what basically you are looking for. To make your comments, so the point of the discussion board is that to provide you the information you need. Provide the information you need to get a good grade in your assignment, get a good grade in your lab. So use it in a way that is going to be constructive for you. It's providing like a general, comments in discussion, never gonna help you, never gonna help anybody else. Just be positive in your comments and be specific about the question that you have. Say, okay, this is part of my code. Line 1, I did this. My understanding that when I move, for example, some numbers into this register, something should happen so that when I add it, this is my expectation. But right now I'm not getting that. So what do I do? This is a fair presentation of a problem. And some students, unfortunately, they don't watch the lecture video at all. Not the lecture video, not the video for lab, and they come and comment, oh, we haven't seen this, we have to go and do the search. Are we supposed to do the search by ourselves in Google? So first, watch the video for the lecture, watch the video for the lab, then say that, okay, in lab 1, I watched the video, it says this. In video lecture, I read that it says this. And now, I'm confused about this and this, how I can tie this together. Yes, you need to do a bit of searching. For example, when you are working with Linux, you are getting different errors. You can type your error in Google and see what the error is. This is something that all of us do, even me, like writing, like I have to deal with different kind of programs. Right now I'm teaching you like assembly, I have to go somewhere teaching like C, somewhere else I have to deal with Python. I'm teaching artificial intelligence students, I have questions about Python, I have to do that. So do I remember all this syntax? No. I have a cheat sheet here. I take a look at the cheat sheet and I know the base, so then I use it. So for you is the same. The expectation is not for you to memorize each syntax. The expectation is that how to use those syntax. All this cheat sheet gonna be in front of you. Even if you go to the industry, you can have cheat sheet for your, if you're working in C++, you can have a cheat sheet over there. Even you can have a cheat sheet for your Linux. When your manager comes, it doesn't say, oh, why you have cheat sheet? You don't know that the job that you are doing? No, never they're gonna ask you. So when I was in industry, everybody has cheat sheets about Linux. So because the people are dealing with so much things and they don't have the time to memorize things, they just take a look at cheat sheet and they find out. In the case that they can't find it out, they just search it. So that's the point. Are you supposed to search Google? Yes, you're computer science. Every day you're gonna get like tons of 100 difference of error that never been taught before. Yes, this is a way to practice that. Let's get back to the lecture. All right. So at the beginning of this lecture, we have two. Okay, we said that, okay, don't care about this. That's okay. So let's take a look at this. So what does this mean? So you have prompt 1 goes to EAX, and then we call this print screen. This is a macro that we're using, right? So what is prompt 1? Prompt 1, you come down and take a look at prompt 1 in the dot data section in here. Okay, prompt 1 is defined by, basically you define byte in the memory, and you have this string of numbers. You define byte in the memory, and this is the initialized data. So each of these alphabet, E is going to take 1 byte in the memory. How the E is stored in memory? ASCII code of it, right? So we have a keyboard of data and alphabet, each of them a letter. So when they come to the computer and to the memory, they convert it to 0 and 1. So we have an ASCII coding sheet uploaded into the canvas. You can take a look at, for example, for letter A. So what is the binary that's going to be represented in the memory? So when you say enter, for each of these letters in the memory, you are going to allocate a space and put E in 1 byte and N in 1 byte. So it's going to be basically start from one side of the memory and going to end. And all these, including this space, is going to be stored in part of the memory for you for later use. And this is the 0. This is basically the null terminator when the print string gonna be used for. So when the print string see this, it's going to go to the next line, understanding that this is the end of that string. So we are using that. And then we have different comment in here. We have prompt 2 enter another numbers. And this is another like distractor questions asking you something different. And then we have the output message. Okay, so when you do the calculation with these two numbers, you're gonna tell the user, okay, the summation is this. So basically that's that. And then you have another output message here defined as this one. What is this basically means? It says times 70 defined by a star, meaning that there's an output message somewhere in the memory. If I want to give a label output message 2, okay, what's going to be in the output message 2? It says times 70, means that you are going to store something for 17 times in the memory 1 by 1 until the 17. What is that? It's basically the units are defined as a byte and the value is a star. Basically put 70 star in the memory. Why we do this? When you run the program, you will see that after you finish program, it says that, okay, the program successfully executed, and there's going to be a bunch of star printing after that message for you. Again, so this is just for you to use here. We are going to talk about this keyword in the future lectures. So this is all for you to use for this one. So you are not required to basically code this, but you understand what this means. So this is your data section. Okay, so let's go back up and see what this code means. Okay, so we put prompt 1 into EAX register and we call print screen. So some student may come and say, okay, I don't know. So why do they call print screen? What does it do? So the answer to this question is that we have a table in one of the lectures. It tells you that when you call print string, what is the expectation from you as a programmer? Because you are dealing with registers, right? When you call a macro, you need to know that macro deals with what register, right? It is not like C, that something happened like magically for you. It's not. You don't have that expectation. So you need to know when you call a macro, what are the registers involved in this macro? So you have to kind of program some register in order to use a macro. So you need to know that, okay? So whatever you are doing during the program, you need to have a crystal clear idea of what it is doing. Okay, in here, we said that when you use a print screen, right? You need, you probably have a message stored in the memory, right? You give the address of that part of the memory to EAX register. Once you call print a string, basically print a string gonna go take that starting address and start printing the content of that address on the screen one by one until it reaches the null terminator. And for us is that we put prompt one, I show it to you, is this one, enter number 1. It's going to give the beginning address of this string in the memory to EAX register. So once you call print screen, it's going to write to the screen each of these one by one. First, it's gonna grab E and put it on the screen. Then it's gonna grab N and put it on the screen. It's gonna grab A and put it on the screen. And it's gonna grab R, and finally this, and finally this terminator in here as a 0. So when something's, when you are stored this one in the memory, when that string finishes, the software automatically should add 0 as null terminator in it. In here, I put one addition 0 to make sure of that. So now I'm gonna have one null terminator created by the hardware itself, and I have added one of my own. So I said, don't forget null terminator. Basically, it is not needed. The software should do that automatically, but I have put that in here. Okay, so it's gonna read all these alphabets and put it on the screen for you. This, which command? This command. So this is the command that's gonna do that for you. So this command. So once it's reached the null terminator, it's done. And it's gonna go back, and your program gonna get another, basically gonna go ask the keyboard to give him one other input. So this is a range integer command. It is also a macro that you guys have been using. Again, so what does this macro do? So explained it before, and this is in the lecture slide. It is in the textbook. If you don't know how this related to other register, this called read integer is related to register EAX. So once you read something from the keyboard, it has to go somewhere, right? It has to go somewhere. Who defines that somewhere is the programmer. Programmer defines, okay, you read this one. Can you please go and put it in the memory location, input 1? Then the software does that for you. How? So when you call read function, you're gonna read something and put it in EAX register. And then using the move command, the command that you guys know very well, then it's gonna take that value and put it in the memory location called input. What is this bracket for? Can we not put this bracket? No, you have to put this bracket. This bracket basically dereference your input. Your input is kind of like memory address. If you want to say that, okay, put the content of EAX into this location, if you say input 1 basically having the address of that memory location. So you have to tell them, take this number and put it in the memory that is specified by this address. So it doesn't put it in that address. It goes to that address. There is a memory allocated for that specific address. Then it put the content of EAX in this address point, in this memory location pointed by the memory pointer, which is the input 1. So now you have a pair of data and address. That's it. So it's read, put it in EAX, and then put it in memory. Some of you say that, okay, can we just like read it and put it in memory? No, because the macro is defined as, so whenever the way that they implemented is that we read the data, you put it in the EAX register. Whatever you want to do as a programmer, it's up to you. That's the easier way for everyone to do. So whenever we read it, this macro is going to put that value in EAX register. Now we want to put it in memory location, go ahead and do it. How? Using move. So we define this input 1 as an uninitialized variable here. Therefore, you basically allocate a space for it. So input 1 is known to your program. Once you read, you can put some data in it. That's it. Let me see if there is any question about this. For some reason, I have to stop share to see the comment. Yeah, okay. One question we have from Juan says that, can we overwrite the data you store in input one later if you want to use the space again? The answer to this question is yes. That's basically a memory location, and you can write on it multiple times. You can read from it. So it is basically the space available to as a container or as an intermediate variable we can use. You can do whatever you want with it. You can define many of them, input 1 to input 10, based on the required number of initialized data in program. Okay, let's go to the next one. Next one, okay, now we read some value, put it in the memory location, and then you're gonna tell the user, you can input another number. Remember this one, this is the same as this one, right? Now, let me create line number in here so that you guys can see the number. Set number. Okay, so one of the useful Vim command is set number, right? So when you open your source code, basically you don't have any numbering in your file. And sometimes when you get error for your assembly file, it tells you which line, right? It tells you which line. And to know that to create line number in your code, you basically need to use the set number. Set number. How do you use the set number in Vim? You basically put the column, right? Column, small column. No, that's a column, double column, right? And then it says set number, and then you say enter, then it's going to provide you this number in here. You see that this is not line numbering. By default, it doesn't create those numbers to make your code simpler. But if you want to do that, you can use the set number to take the number in your code. Okay, we explained this one. So for this one, we send a message to the user, enter the number, the user then. So okay, when we send that, then we need to make the keyboard prepared to read the number. So once we call this read integer, this integer basically is going to call this macro. This macro is kind of waiting for the keyboard to give him something. As soon as the user inputs something, right, then the data goes to EAX register. Then we get the data and then we put it to input 1. And then for the second number, we send the message to the user, please enter your second number. And immediately we tell the keyboard, okay, keyboard, be ready to get those data. I want this data. So this data is coming. And then they are going to go to EAX register. Similarly, they're going to go to input 2. Continue recording. Okay. 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 Hopefully my mic is gone. Hopefully you can record my voice. Can you guys hear me?
Yeah.
Yes, sir.
Okay, you guys can hear me, but I can't hear you guys. Microphone. Still, you guys can hear me?
Yes, sir. We could still hear you.
Okay. Let's see. All right. It's good that you can hear me, but I can't hear anyone. So can anyone speak out?
Testing.
Oh, I can't hear you. Okay, let me go on and finish this one because I'm recording right now. I don't want to interrupt recording. And at the end, I'm gonna kind of reset the Zoom so that if you have any question, I can hear you. But meanwhile, you can use chat room to post requests. So hopefully it's going to be recorded.
Okay, so so we read the second input, we put it in the memory location called input 2.
Daddy.
Yes, Daddy.
Okay.
Okay. Okay, so we put it into input 2, and then next time what we want to do is to basically add this to number and then print this to number, right? So this is the prompt tree that says, okay, for example, the addition is this. So what we want to do in here, in this code, right? So we move input 1 into EAX register, and we say, okay, add EAX register, which is input 1 with input 2. So these are the same size, there's going to be no conflict. Therefore, it's going to add this to value and put it still in EAX register, right? We put in EAX register, then we copy EAX register to EBX register. Why? Because I want to use EAX register to print something on the screen, right? I want to print some message into the screen, and if I keep the addition at EAX register is going to be overwritten, and then I'm going to be losing the value of the addition. Therefore, I'm moving into another register, and then print my message on the screen. And once I print my message on the screen, then I can, for example, create another print integer to print the result of the add into the screen. This is one of the activities that's asked you. Add a line or 2 lines in the code so that you can print out the result of the add on the screen. So this is one of the tasks that has been asked from you. Just add it somewhere in here in the code. I don't tell you where exactly. You have to figure that out when you run your code. That's the task that you need to do. And that works with the EAX register. Just be careful what you put in EAX register and the sequence of the command that you're printing out. This is important, okay? Not a difficult task. It's going to take you 5 minutes, but you need to run the program, see the output, check this output message prompt, and figure out where to put that print integer macro for your program. That's a simple one. And the other activity that has been asked for this. So the first one was to include the necessary files. The second one was to provide comment in front of each line, saying that what each line does. For example, in here, you say that the content of the memory location input 1 is copied to register EAX. And in here, you say that the content of the memory location specified by input 2 is added with EAX register, and the result goes to EAX register. So these are the sort of comment that I need you guys to add to your file. I just want to know your understanding about how to program in this code, in this activity. Okay. Let me see the last one. Add a snippet for a file to print the add operation. Then what are the value of the EBX, CX, and DX register? So let me share you this one. Okay. Let me show you the lab. Here you go. Okay, this one says that what are the content of this register, EBX, CL, DX register. So how do you know that what the content of those registers are? What do we do? It says that after the add operation. Anyone has any answer for this one? Jump in and please post it in the chat. I'm expecting to get 35 answers in the chat. Let's see. Okay. So couldn't you move register into EAX after clearing it, then print that? That's a, Francesco, that's a hard way to do it. Yes, you can, but that's a hard way to do it. Could you do the register dump? Yes, Alex, yes, that's the correct answer. And yes, that's the good answer. So using, once you do the add operation, right? Immediately after add operation, you use the dump register command. And then once you say dump register command, all those registers are going to be printed out for you on the screen. One thing to know is that you need to kind of decode this one: EBX register, CL register, DX register. All those registers that are going to print it out on the screen going to be E version of it. Means that 32 bits register, right? For EBX, that's okay. That's what you see you put in here, right? But how about for CL? What is CL register? Does anyone know what the CL register is? Dominic? Is the first 16-bit music exist? Good, 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 Francisco, that's correct. Once Owen says that it's part of ECX register, yes, it is part of the ECX register, but you need to code it. Alexa says that it's 8-bit register. Yes, oh yeah, we are talking about the CL register. Yes, it is 8-bit register. CX register is 16-bit register, and it's the first part of the 32-bit register. Yes, Alex's answer is correct. It's the 8-bit register, and that 8 bits is the first 8 bit of the ECX register. We explained this in one of the lectures, but I guess the second lecture slide has this one. It shows the relation of the ECX register, AX register, and CL, CX, ECX, and RCX. RCX is a big one, 64-bit, ECX is 32-bit, CX is 16-bit, and CL is 8-bit. Yeah. Okay, so when you code that, take a look at your dump on the screen and see the ECX register and take the value, the 8-bit value of it, and then say that CL has this one. So we can do this in here. So for that, when you have questions, so explain what the question. So let's put the question mark over there. Please let me know what you mean. Okay, let me show you this one. So I just want to tell you, okay, how you do programming. Is it something that comes from like okay, now we said, okay, after the add operation, tell us what the register content are. So you use dump register, right? Dump regs, and then you give it a label, right? You give it a label. And then, for example, here we say label 1. Guys, now I'm not sure whether the syntax that I'm writing here is correct, because I remember this from previously, dump regs gonna dump. I might be wrong about this spelling, or I might be right? So how do I could go with this? I need to go and check the command dump regs from the slider from the textbook, right? Yeah, I'm not sure. But now I give it a try. I'm hoping that this is basically the corrected one. So even I'm your instructor, right? I don't know what this exact syntax is. So don't think that is something like when you are writing code, is something magical that you have a drug or something and then you're going to be expert. You have to do practice. So 2, 3, and then of course this one is 5. Here you go. So I was lucky this time, so I just tried dump regs and it's print that out. Maybe next time when I want to put the command, maybe I put regs dump. So, but I know what the command is, but I don't remember exactly the spelling. So now I just try it, and next time when I want to do it, I take a look at the cheat sheet in front of me to use the correct one. Okay, off tangent, enough talking and explain here to me, what does that mean, CL register? Okay, let me go back in here. Probably you guys don't see this screen. Okay. Okay, so I guess you guys right now see the screen. So I put the dump regs in here, and I just run the file, and I got these values. I dumped this register. As you can see, the flag register is here, and a bunch of other registers are here. And one of the questions was, what's the content of the CL register? So this is ACX register, and CL is the 8-bit, the lower 8-bit of this ACX register. Basically, for this, the answer is that CL register is 20. What if we say that CX register? CX register is the lower 16 part of the ECX register. It's going to be E720. What if we said E6 register? This is E6 register. And we also ask for EBX register. Okay, that's it. Stop this. Back to the law, right? Okay, let's share this again. Okay. E. Is it what are the value of the carry flag, sign flag, overflow flag, and after the add operation? Okay, so once you add that dump register there, then you have the flag register value, and then you decode it as you did for the previous slide. So you did this, you got 50. Good, sweet. And now you're at activity 2. I want to take a break for 5 minutes. And we're going to go back at 11:02. In case you are good and you understand how to code multiplication from the lecture video and the lecture slide that's provided, it's good, you can leave. But if you don't know, you watch those videos and you don't know how to do the multiplication using addition, then you can stay here. I'm gonna briefly, maybe for 10 minutes, explain this, and then we are done, okay? Now, we take a break. Okay, everybody. Let's very quickly explain how we can do the addition, multiplication using addition operation. It is recording, that's good. Okay. Let's see. Okay, I have a good whiteboard here. I'm gonna use that whiteboard. All right, guys, let's do this together very quickly. I know that you guys might have something to do, but let's do it together. So assume that we want to compute this value of x. We want to compute 2 multiplied by, is this? We want to multiply 2 by 3, right? So what does this mean? It means that anyone 2 by 3 means that you have to add 3 2 times, right? Basically, it's this one, 3 plus 3, right? So 2 by 3 means 3 plus 3. Assume that we have another expression that is, okay, 4 multiplied by 5. Now, 4 multiplied by 5 basically is this. You add 5 by itself for 4 times, right? So this is the concept. So answer in here is 6, and in here your answer is 20. So this is what we want to do with this program. So we want to take 2 integers from input. For example, you can start by saying that, okay, read int. So you say call read int. So when you call it, then the value input by the user is going to go to EAX register. Then you use move command to move that in your input 1, right? And you know that value is in EAX register, right? And you do this for the second one. And right now in your memory, right, you have 2 variable, input 1 and input 2, where your user input are basically located in those memory location. Assume that there are 2 and 3, right? So you have these 2, and right now you need to basically write a for loop that kind of comes and do the addition, for example, for 2 for 3 times, right? Or for 3 2 times, if that doesn't matter. So if you take a look at previous lecture, let me show it to you. Basically, the code is provided to you how to do this. And I want to quickly show it to you in case you are kind of past that quickly and didn't see it. I would like to write it one line by line. I see that we are kind of out of time. So I want to show it to you here very quickly. So let me stop sharing that. And going through the code. The code is basically here in the lecture slide. So you just need to understand that. Okay. All right, so we have used called read integer to read numbers, right? You guys can see this screen?
Yes,
The
sir.
screen for the code?
Yes, we can see the lecture slides.
Okay. Okay. Let's see. perfect. So we read 2 integer number from the keyboard using this macro, and then we initialize EBX register with 0. I explained this one in the lecture video, so just if you don't know that. So this is the concept, right? You are going to add basically EBX register with EAX register and decrement the value of the ECX register. And if jump not 0, going to repeat this again. So the value of the EBX register is 0. So basically we add EX with EBX register and we put it in EBX register. And then we add EX register as much as ECX time, right? You remember that we first read the first input, put it in ECX. We didn't use the memory in here, but it doesn't matter. You can use memory or you can use directly the register to do the multiplication. And we read the second number. The second number right now is EAX register. Basically, right now what you are doing is multiplying ECX with EAX. And then you put the result in EBX. And finally, when you calculate the result, you put the result back into EAX and then you print it out using this macro. And then you are done. That's pretty much it. So one of the important things is that, so when you are adding register EAX with register EBX, right, you need to decrement the value of register ECX. So assume that you want to multiply 2 by 3, so your register ECX is 2, and your register EAX is 3. So then you use EBX register to do this as an intermediate value. So then you say EBX is equal to EBX plus EAX. In the first round, you add 3 by 0, and your EBX is going to be 3. In the second loop time, then you come back, because the result of register ECX is not yet 0, therefore you jump back again into the code. In the second time, then you add register EBX with EAX again, which is 3 plus 3, and then you get value of 6. And then in the first round, you deducted the value of register ECX for 1 time. So in here, your register ECX is basically 1 in this iteration. And now you do this iteration, and then you deduct the value of the ECX register. Now your ECX register is 0. Now your ECX register is 0. You do the addition, you got 6, and it says jump not 0 L1. But right now the value of ECX register is 0. Therefore, you don't jump in here. You go to the next line. Next line, what you do, you move the value of the EBX, which is 6. You put in EAX, and then you print that out. That's as simple as this. Okay, if I stop sharing, that's pretty much it. It's a code that you need to put together, and you see that how simple it is if you know the jump instruction that we explained in this lecture. All right, so I'm not going to take attendance because I see that some of you guys, some of your friends has left. And then I wanted to talk to a few of you. If I have emailed you during the week to talk to you, please stay on in here. I want to talk to you. If I haven't sent an email to you that I want to talk to you, please feel free to leave. Go and do the lab, and if you have question about that, post it in the discussion board. Thank you, everybody. So, but I wanted to, those of you that want to talk to, please stay on.